Hello everyone. On this video we will be looking at hexagons and irregular polygons. Okay. Now a regular hexagon is just a polygon with 6 sides. Okay, before we saw the triangle with a polygon with 3 sides, a square and a rectangle are polygons with 4 sides, which are quadrilaterals. These are just polygons with 6 sides. Okay, where each angle is 120 degrees and all the sides are equal length. So if one side is 5 inches, then all the sides will be 5 inches. Okay, now if you wanted to find the area of a polygon and you know the length of the side, then you use this formula where the area is equal to 3 times a squared times square root of 3 over 2, or you can rewrite it as 3 square root of 3 over 2 times a squared. Okay. Now, if you want to find the distance across the corners or across the vertices, okay, from this vertex to this vertex, or this vertex to this vertex, or this vertex to this vertex, they will all be the same length. Okay. Now, to find the distance across the corners, you use the formula, the distance equals 2 times whatever the length of the side is. So 2 times a. Now, if you know the length of the side, you can still calculate the length from corner to corner. And you just get this formula, divide both sides by 2, and you can solve for a. So a would equal the distance across the corners divided by 2. All right. Now, move that up a little bit. Let's say you wanted to figure out the distance across the flats. Now, the distance across the flats is literally just from this flat side to this flat side, or this flat side to this flat side, or this flat side to this flat side. And it's written in green. So if you have the distance across the flats, you can find that out by F is approximately equal to 1.732 times A. Now, if you know the distance across the flats and you want to solve for your A, which is the distance of the side, you can just divide both sides by 1.732. So you have F over 1.732, or you can write it as 1.1 over 1.732 times F, which will give you approximately 0.577. So to solve for the side A, you get A is approximately equal to 0.577 times the distance across the flats. Okay, so once again, this is the length of the side, which is your A. The distance across the flats is your F, and the distance across the corners or your vertices is your D. All right. So if you're still writing, of course, feel free to press pause and finish up. But we're going to go ahead and move on to the next page. All right. Okay. So for our first example, let's say we wanted to find the area of a hexagonal plate 4.0 inches on each side. And we want to round to 2 significant digits. Okay? Now, we know that, actually, what I want you to do is go ahead and press pause and try to solve this one on your own. All right, so I'm assuming you've pressed pause and tried this one on your own. So we know that the area of a hexagon is equal to 3 square root of 3 over 2 times a squared. Okay, so what if we went ahead and plugged this into the calculator? We'll get the area is approximately equal to this value, which comes out to be 2.598, times your a squared. We know in this case, a is equal to 4 or 4.0. So that's 4 inches squared. Okay, so that means this is approximately equal to 2.598 times 16 square inches. Okay, so if we go ahead and multiply these two values together, we end up with 41.568 square inches. Okay, but if we get this and round it to two significant digits, we end up with 42 square inches after we round it. Okay, and remember, square inches and square inches, these two measurements are the same. All right. So if you are still writing, of course, feel free to press pause, but we're going to go ahead and move on to our next example. There we go. Okay, so what if the cross section of some hexagonal shape measures 3/4 of an inch across the flats? Find, first thing you want to do, you want to find the length of side A. And then you want to find the distance across the corners. And then you want to find the area. Okay, so I kind of drew this hexagon here, and the distance across the flats is 3/4 of an inch. So what I want you to do is press pause and try to solve this one on your own. All right, so I'm assuming you've already pressed pause and worked this one out. So let's go ahead and verify your answer. Okay, so we know the distance across the flats is equal to 3/4 of an inch. We can go ahead and convert that to a decimal. It'll just be easier to work with. So if we convert that to a decimal, it's 0.75. Oops. Okay, so now let's go ahead and solve problem A. We want to find the length of A. Okay, so we know that A is approximately equal to 0.577 times the distance across the flats. Okay, so that means this will be approximately equal to 0.577 times F, which is 0.75. So that means your A is approximately equal to, once you plug those two into your calculator, 0.433 inches. Okay, so that's your length of A. Okay, so now we want to find the distance across the corners, which is our problem B. Excuse me. Okay, and our distance across the corners is D. Okay, so we know that D is equal to 2A. Oh, let me move this up a little bit. Okay, so if D is equal to 2A, that means that D is equal to 2 times 0.433 inches. That's our A value. Okay, so we go ahead and multiply those two, and we end up with the distance across the corners being equal to 0.866 inches. Okay, so now we want to find the area. Move that up a little bit. Okay, so we know that our area is approximately equal to, again, we know it's just from the previous example. I'm going to cover this up for a second. A equals 3 square root of 3 over 2. But if we plug that into a calculator, we get 2.598. Okay, so 2.598 times A squared. Okay, so we get 2.598 times A squared, so that's 0.433 inches squared. Okay, so 0.433 squared will give us, so we have 2.598 times 0.1875 square inches. And that's just the 0.433 times 0.433. That's how we ended up here. Okay, so if we go ahead and multiply these two together, let me move this up a little bit more. We have 0.487 square inches. All right, so remember, sometimes you might be a little bit off on your calculation. That just means in some cases, depending on the problem in the textbook, a equals 3 square root of 3 over 2a squared is the same as a is approximately equal to 2.598 times a squared. Okay, so a lot of times if you plug in this one and your answer is a few decimals off, just try this one. Or if you try this one and your answer is a few decimals off, try this one. Okay, so it kind of varies. Remember, this is just an approximation. So sometimes, depending, like I said, depending on the textbook and the particular problem, the approximation is what they're looking for. Here you have your exact value. Here's the approximation. Or sometimes they're looking for the exact value. In this case, you'll use this one. So it kind of varies. But like I said, just be familiar with both, or be familiar with using both. All right. So if you're still writing, feel free to press pause and finish up. But we're going to go ahead and move on to our next example. Well, not next example, next section. And that's irregular polygons. Okay. Now, with irregular polygons, normally we have just regular triangles and rectangles and squares. But sometimes you'll have a shape that's not just a regular shape. It's odd shape, like this one in this example. Okay, so what you do is you take that odd shape and you break it down to regular polygons. Okay, so I'll give you an example here, but I want you to try it before I do. Okay, so I want you to find the area of this entire shape. So we know from this vertex up here is 20 inches. From that same vertex down to the bottom is 32 inches, and it's 16 inches across. Okay, now to kind of give you a start, I want you to try this on your own first. I want you to look at how I started. What I did was I turned this odd shape into two shapes that's kind of familiar. So instead of one odd shape, I turned this into a triangle and a rectangle. Okay, so we know if this is 16 inches apart, then from here to here is 16 inches apart. Okay, so what I want you to do is press pause and find this area on the own. So remember, find the area of this shape and this shape, add them together. All right, I'm assuming you've pressed pause. You've worked this one out. So let's go ahead and verify your answer. Okay, so we want to find the area of this shape here. So what we're going to do is we're going to take the area, or the total area, is going to equal the area of this triangle plus the area of the rectangle. Okay, now we know that the area of a triangle, let me clean that up a little bit. There we go. The area of the triangle is 1/2 the base times the height, plus the area of the rectangle. Remember, that's just length times width. All right. Now, we're just going to work that out right here. So 1/2 the base times height. You can have it as 1/2, or you can change that 1/2 to 0.5. It's completely up to you, but just 0.5 seems a little easier to work with. Okay, so you have your base, which is 16, times your height of the triangle, which is 20, plus the area of the rectangle, which is length times width. So you have length times width, or you can say length times width, doesn't matter, it'll give you the same answer. So you have 32 times 16. Okay, so we have the area of our triangle, which is here, and we have the area of our rectangle, which is here. Okay, so that means your area will equal 0.5 times 16 times 20 is 160 square inches, plus 32 times 16, which is 512 square inches. Okay, so we know that our area, I'm just going to write little arrows here to let you know these are separate steps. There we go. So we know the area is going to equal 160 plus 512, which is 672 square inches. All right. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our next example. All right, now for this example, I want you to find the area of the shaded region. Okay, you want to round that to the nearest tenth. All right. So once you do that, well, before you get started on that, remember, each side of the outer triangle is 3.8 centimeters. And I didn't want to write it inside of here too small, but each side of the inner triangle is 1.6 centimeters. Okay, so you have an equilateral triangle on the outside and an equilateral triangle on the inside. Okay, so what I want you to do is press pause and try to solve this one on your own. All right, so I'm assuming that you've already pressed pause and you worked this one out. So let's go ahead and verify. Okay, now to find the area of the shaded portion, that's going to equal the area of the entire triangle minus the area of the inner triangle. Now, if you wanted to, you could say the area of the outer triangle minus the area of the inner triangle, same thing. It's all just wording. So when I say the area of the entire triangle, I mean the area of the whole thing. So you could say outer triangle, but the area of the whole thing minus that whole. So it's kind of like if you have the area of a donut. You get the area of the entire donut minus the hole in the middle. Same thing here. Okay. Now, just the fact that we know that each side of the outer triangle is 3.8 centimeters, we know it's an equilateral triangle. All sides are equal. And we know that the sides of the inner triangle, all those are 1.6. So we know that's an equilateral triangle. Okay, so we know we're going to be using an equilateral triangle for both of these. Okay, so we know the area is going to equal the area. Actually, let me write the formula first before I get going. Area of equilateral triangle. Okay, so remember that's the area is equal to 0.433 times a squared. Okay, so now going from up here, I'm just going to bring that down here. The area of the shaded portion is going to equal the area of the entire triangle. Remember that's an equilateral triangle, so it's 0.433 times a squared. In this case, it's 3.8 centimeters squared. Minus the area of the inner triangle, which is 1.6 on each side. So that's minus 0.433 times 1.6 centimeters squared. Okay, so this is going to equal 0.433. Remember, 3.8 centimeters squared is 3.8 times 3.8. So that will be 14.44 centimeters squared minus 0.433, 1.6 squared. Remember, that's 1.6 times 1.6. So that's 2.56 centimeters squared. Okay, so if we go ahead now and multiply these two values, 0.433 times 14.44, we will get 6.2525 centimeters squared minus, now we have 0.433 times 2.56, 1.10848 centimeters squared. Okay. So if we go ahead and subtract these two values, we end up with 5.14402 centimeters squared. And if we round that to the nearest tenth, we get approximately, let me move that up a little bit, there we go, 5.1 centimeters squared as our rounded value. All right, so hopefully this made sense, and I will see you on the next video.